Hi students, good evening. So we are in the 12th session of the laws of motion topic. In Canada, we will try to look at the idea of impulse, and then we'll talk about the rocket propulsion. So in the area we already got at least in the last 20 years we got around last 20-25 years we got around 4 or 5 questions on the rocket propulsion. Okay, that too on one simple concept. So that we'll see. We'll also try to cover the idea of inertial and non-inertial frame of reference. Then we'll be able to understand once we go to the discussion on that. So this is the concept of inertial and non-inertial frame of reference, right? This is with regard to the observer. With regard to the observer, how do we classify the study of motion? So depending upon the observer type, right? In some cases, we'll call the observer as the inertial frame of reference. In some other cases, we'll call the observer as the non-inertial frame of reference. Okay, va? So we'll go and discuss about each of them. First, we'll start with the concept of impulse. Impulse, right? It is simple as it's a measure of impact of force acting on the object. So for example, there is a force acting on the object. So the impulse will be what it represents, the measure of impact of force acting on that particular object. So how is this impulse measured? It is measured as, for example, if the force is a constant force, if the force is a constant force, it is acting for a time delta t. What is the time for which the force is acting? Delta t. Then the impulse is measured as simply force into time for which the force is acting. So everybody, how do you measure the impulse? It will be what? Simply force into the time for which the force is acting on the object. Already if you look at the Newton's second law of motion, right? Adhilenna we will talk about the relation between the force acting on the object and change of momentum. Okay, so what is it? Force acting on the object is equal to what? Rate of change of momentum. Force acting on the object is equal to what? Rate of change of momentum. Dana. So again, we have to keep in mind that both force is a vector and the momentum is also a vector. So if you rearrange them, right, the delta t matto on the left side, that it will be what? F into delta t will give us what? Delta p. What is this? Change in momentum. So impulse, define what is it? The force acting on the object multiplied by time for which the force acting is on the object. A numerical value will be equal to what? Simply change in momentum. Impulse or a numerical value will be equal to what? Simply change in momentum. Okay. Now when we look at what will be the SI unit of the impulse and what will be the dimensional formula, it will be same as the momentum. So the SI unit of impulse will be what? Impulse or SI unit will be what? It will be SI unit of momentum, which is what? Kg into meter per second. Similarly, what will be the dimensional formula of the impulse? Same as the dimensional formula of the momentum. What is the dimensional formula of the momentum? ml t power minus 1. Dana. So the dimensional formula of impulse also will be same. Okay, va? So this is how we'll measure the impulse when the force acting is a constant force. Okay, va? So this is how we'll measure the impulse that is created by a force acting on the object. And we can have the force also as a variable force. Variable force and the value of the force will be changing. Okay. Variable force means what? The value of the force will be changing. So in that case, how do we calculate the impulse? So constant force, then it will be very simple. And the force we'll just multiply force with the time for which the force is acting. Adilandi we will get the momentum. But if the force is a variable force, constant force illama, if the force is changing with respect to time, then what we will do is we will have to take the integration approach. So how do you calculate the impulse in that particular case? We will have to take the integration approach. We will look at it. So how do we calculate the impulse if the force is a variable force? So we are looking at calculating the impulse when the force is variable force. We will take a small time interval dt. We'll take a small time interval dt and we will multiply force at that instant. Without the instant of time, we will take a very small time interval. So this dt is called as what? And we will call it as what? Differential time element. Other than a differential time element, which will be very small. We can't even measure how small it is. If you want to find out what is the total impulse, means we have to integrate this from the initial time to the final time. Generally initial time will be what? T is equal to 0. T is equal to 0 and we have to integrate it up to whatever time they are asking. Okay, so we will calculate the impulse in case of the variable force. So if the force is a variable force, right, we can calculate the impulse by using the integration approach. Then there is also one more method. In the integration method, we also have one more method, that is graphical interpretation. Another graphical interpretation. But we should be given the graph. Then only we can calculate the impulse using the graphical interpretation. Okay, so if the force is a variable force, right, we can calculate the impulse without using the integration method. But for that we should be given the graph. So if say for example they are giving us the force versus time graph, the force must be the y coordinate and time should be the x axis. Force is represented along the y axis and time is represented along the x axis. Okay, then look at this. What is the impulse as per the integration formula? We have T1 to T2. So we are looking at the measurement of impulse from T1 to T2. T1 to T2 f dt. This is what will give us the impulse. If you take a very small time element, dt namma at this particular time the force is f. So what is this f into dt? What is this f into dt? It is the area of the small rectangle. So what is the f into dt? Area of the small rectangle. For integration and so what is integration means? Summation. Integration means what? Summation only, right? Means we are adding up all these f dt values. F dt அப்படியே நம்ம add பண்ணா what is it that we are going to get? Total நமக்கு என்ன வரும்? We will be getting the area between the force curve and the time axis. So the graphical significance of this integration, and what is the graphical significance of this integration? It will be giving us the area between the force axis and force curve. The area between the force curve and the time axis. Time axis on the x axis. The curve is what? Curve is representing how the force is changing with respect to time. Okay, so the area between the force curve and the time axis, that will be giving us the impulse. So wherever they are asking, right, they are asking from T1 to T2, then we have to find out what is the area. Already nam in the madri problem solve pannirupom, like finding the area between the curve and the x axis. Okay, so we just have to choose particular geometry. Usually they will give us triangles, rectangles, square. They will try to give us some symmetric geometrical shapes. Other than they will try to calculate what is the area between the force curve and the time axis. That area is what is the impulse value. All of that. So this is what is the graphical interpretation of getting the impulse. இதுல ஒரு பாயிண்ட் இருக்கு, என்ன தெரியுமா? When the force curve is going below the x-axis, so பாருங்க, like say this is going like this, then the impulse, right, that is calculated above the x-axis, we will have to consider this area as what, positive, and the impulse that is created below the x-axis, we have to take this as what, negative. Okay va? So because impulse is what, it's a vector, it's not just a scalar quantity, it's a vector quantity, right? Adanala what we need to do, if the impulse is coming above the x-axis, means that will be positive, and any impulse below the x-axis, right, that much amount of area we have to take it as what, negative. Adu nama negative edukano. So if they are asking what is the total impulse, means we have to do what, I1 plus I2 dana, that will give us what is the total impulse. But pannabodu we should keep in mind that whatever the area coming below the x-axis, right, and the value number negative edukano, because the one that is above the x-axis represents positive impulse, and the one that is below the x-axis, right, then it represents the negative impulse. Okay, so whenever it is coming like that, graph in the x-axis scale up ponachkonga, then we need to be careful. Okay, அப்படி இல்லன்னா it will be very straightforward, அந்த ஏரியா மட்டும் calculate பண்ணா we will get what is the impulse. இங்க பாருங்க, these kind of questions we can have, like the questions on the impulse in case of the variable force. இங்க பாருங்க, a force of 2t plus 6 newtons is acting on an object for 4 seconds. What is the time for which it is acting? 4 seconds. What is the total impulse acting on the object? They are asking what is the total impulse. See, this force is acting for 4 seconds. We have to take our time as what, 0 to 4 dana. We have to take our time as what, 0 to 4. So what is this? It's a variable force. Paranga, force is changing with respect to time. What is the force function? 2t plus 6 means force, it's a variable force. So impulse eppadi calculate pandrathu, using the integration formula dana. What is integration formula? Integral f dt. Integral f dt. Idhila we have to take the integration limits as what, 0 to 4. The impulse we have to calculate for 4 seconds, means we'll start our journey from 0, adalinde we'll go up to 4 seconds. Okay va? So inga paranga, we have to substitute the time function 2t plus 6 dt. Appo we'll just split the integration. Already nama basic mathematics la paathirkom, how do we solve the simple integrations. And 0 to 4 2t dt, adukaprom 0 to 4 6 dt. Okay, so what is integral 2t dt? T square. T square nama differentiate panna, what we'll get? 2t dt. So integral 2t dt will be what? T square. So t square will come, limits 0 to 4. Idhula 6 அப்படியே வெளியே வரும், உள்ளன இருக்கும். It will be integral dt, right? What is integral dt? T. Limits are 0 to 4. So paranga, what we'll get? So all these basic integration, right, we must be comfortable. Idanadi t square, final limit 4, initial limit, so which is what, 4 square minus 0 square. Idanadi 4 square means 16 dana. Inga enna varum parunga, 6 into 4 minus 0, 4 6 are 24. So 16 plus 24 evada? What is 16 plus 24? 40 dana. So parunga, force is in Newton SI unit, time is in seconds, so the impulse will be coming in terms of the SI unit. What is the SI unit of the impulse? Kg meter per second. So what is the correct answer for this? Check pannunga, what must be the answer we should get? Maximum இப்படி தான் வரும். Like whenever you are having questions on this impulse, right, If the force is constant force means that is very simple straightforward question. Illana they can give us questions where the force is a variable force. Adala you will either have this integration type of questions, illana you will have graph type questions. Okay, here we are not solving graph based example. Already nama graph based questions nariya paathirukom, but not in this impulse case, but in other, like in the kinematics we talked about the graph based questions, right? Same as it is, we'll have to find what is the area between the force curve and the time axis. The area of the value will be what? Impulse. If the force curve is going below the time axis means we have to be careful. So whatever the area below the time axis, we have to take it as what? Negative. Above the time axis, we have to take it as what? Positive. Okay, so this is about the concept of impulse. Okay, check pannunga, you should get the answer as what? 40 kg meter per second. See these simple integrations, right? We must be comfortable. Okay va? Appuram we'll go to the rocket propulsion. So this is an important area, like we have got good number of times questions on this rocket propulsion. So what is this rocket propulsion? So at least most of us, right, would have observed the rocket propulsion. So from the launching station, right, from the launch pad, when the rocket is propelled upwards, one thing we all of us will observe, we will see that there is a exhaust gas that is pushed backwards. So Kandipa, what is it that whenever we look at the rocket fired, right, what is it that we'll observe? We'll see that there is an exhaust gas that is bursting out, it's coming down. So if you look at the reason for the propelling of the rocket, right, the reason for the propelling of the rocket is this exhaust gases. In the madri exhaust gases pinadi varalana, then rocket propulsion would not be feasible. So why the rocket propulsion is feasible? Because of the exhaust gases. Okay, so what is the relation between the propulsion of the rocket and the exhaust gases? Okay, because of the exhaust gases coming back, the rocket is actually propelled, or we'll say in the language of physics, right, we'll say there is a thrust acting on the rocket in the upward direction. Adhanala the rocket will keep on moving upwards. So Pakla, what is the mechanism here? If you look at the exhaust gases, general assumption we'll consider that they are coming back with a constant speed. So wherever the rocket is getting propelled, we'll assume that the exhaust gas are coming back with a constant speed. So we'll say U is the speed of exhaust gases. U is the speed of the exhaust gases. Okay, then if in a time delta t time la, if a mass m of the gases are released, the time delta t, if a mass m of the gas are released, right, for that amount of gas whatever is released, right, initially it is inside the rocket, so we can take the initial momentum to be 0 and final momentum, right, what is the final momentum? It will be what? The entire mass m is now moving with a speed u, right? So we can take the final momentum is what? M into u. So change in momentum, what is change in momentum we will get? It will be final minus initial. Now rate of change of momentum. Rate of change of momentum. This will be what? Change in momentum divided by delta t. Now what is this? This is nothing but the thrust acting on the gases that are pushed backwards. So what is the rate of change of momentum for these gases? It is a thrust that is acting on the exhaust gases which are pushed down. As per the Newton's third law, right? When the gases are pushed down, the remaining part of the rocket will experience same value of thrust but in the opposite direction. So the upward thrust, what will be the upward thrust acting on the rocket because of the exhaust gases? Newton's third law states what? For every action there is an equal and opposite reaction, which means the upward thrust acting on the rocket, which actually makes it to propel upwards. So what is it? The upward thrust acting on the rocket. It will be, what is m by delta t? M is the mass of the gas that is released in a time delta t. So m by delta t will be what? It will be the rate at which exhaust gases are released. So this is what the mass rate. It will be in terms of kg per second, rate at which the gas are released back, into u. U is what? Speed of the exhaust gases. So what is this upward thrust? Upward thrust will be what? It will be the rate at which the exhaust gas are released, which will be in terms of the SI unit around kg per second, into the speed of the exhaust gases, which is u. Okay, so this is what is the upward thrust. So because of the upward thrust acting on the rocket keeps propelling up. If the exhaust gases backside if the exhaust gas are not coming backwards, then there will be no upward thrust acting on the rocket. So it is the mechanism of the rocket is based upon what? The exhaust gas is being pushed down. Adhanala there will be an upward thrust acting on the rocket, which is making the rocket to go up. Okay, so this is what is the main reason for the rocket propulsion. Now when you look at this in terms of the rocket parameters one of the main parameter of the rocket is the mass of the rocket. What is one of the main parameters of the rocket that we consider? Mass of the rocket. So let us say m represents capital M. Capital M represents what? Mass of the rocket. If the fuel is getting burnt, fuel, where is the fuel coming from? Fuel is also inside the rocket only, right? Fuel is also inside the rocket, which means when the fuel is getting it's undergoing combustion, the mass of the rocket will be decreasing. So because of the combustion of the fuel, the mass of the rocket will keep on decreasing. As the time goes by, the m value will keep decreasing. Minus dm by dt will be what? The rate at which the mass of rocket decreases. And a dm by dt will be what? The rate of change of mass of rocket. That will be negative. It is negative because m will keep on decreasing, right? So if you put a minus, means what is this minus dm by dt represents? It represents what? The rate at which the mass of the rocket is actually decreasing. And observe pannunga, what is happening to the mass? Whatever the decrease in the mass of the, say for example in 1 second time 6 kg of the mass of the rocket is decreasing, then what is happening to the 6 kg? Then the fuel, the 6 kg fuel is undergoing combustion. Combustion is a chemical reaction, so mass will be conserved. Whatever the initial mass of the fuel, the final mass of the exhaust gases will be equal. And in case of a chemical reaction, right, the mass conservation is going to be satisfied. So whatever the decrease in the mass of the rocket, right, that is going to come as the exhaust gases. Means the minus dm by dt, which we are calling as the rate at which the mass of the rocket decreases, right, that will be equal to what? The rate of combustion of the fuel. That will be equal to the rate at which exhaust gases are released from the rocket. Why? Because it's a chemical reaction, right? So whatever the fuel combustion, same mass will be coming out as the gases. Okay, so this minus dm by dt is what? This is the rate at which the exhaust gases are coming back. Already we have had the formula for the thrust, right? What is the formula for the thrust, paranga? What is the formula for the thrust? Rate at which the exhaust gas are released into speed of the exhaust gases. So what is it? This is minus dm by dt into u. That's it, right? This is the thrust. So what is it? Minus what is the formula for the thrust? Thrust acting on the rocket at any given instant, right? Adukku formula? Thrust will be equal to what? Minus u into dm by dt. This thrust will be acting upwards. We can say upward thrust. So the upward thrust acting on the rocket will be equal to what? Minus u into dm by dt. Okay, va? U is what? The exhaust speed of the burnt gases. So the speed at which the burnt gas are coming out, right? That is what is the u value. Okay, va? So this is what is the thrust acting on the rocket. Now we look at what is the thing that we need to focus in terms of NEET questions. So if you look at the questions that have come in the NEET examination, right? All the questions, they have come only on this thrust formula based. I think 4 or 5 questions have come. We are going to see at least, I think 3 questions we are going to solve now. But all questions are one concept. All the questions have come from the thrust formula. We already talked about the thrust. What is the thrust? Minus u dm by dt. This is the thrust, right? Now the rocket will also experience gravitational force. Of course, see, the g order value, right, will keep changing. Why? Because the rocket is not going to just go some small height. Rocket is going to go for a considerable height from the surface of the earth. Adhanala the g value will keep changing. The small g order value will keep changing. Okay, va? So if you look at the scenario where we neglect gravity neglect panachkonga, there can be a lot of reasons. Either the thrust value is very high, or when we go far away from the surface of the earth, right, then we can neglect the gravity. So if we neglect the gravity means, paranga, what is going to happen? The upward thrust, that is the only force. Here we neglect the gravity. Upward thrust will be equal to what? Mass of the rocket into, because of this, let's say rocket acceleration, then the upward thrust will be equal to what? Mass of the rocket into its upward acceleration. So this is what is the thrust formula when we neglect the gravity. Neglect panna. When we consider gravity, generally when the rocket is getting launched, right, then we should not neglect the gravity, because we are launching the rocket from the surface of the earth, right? So g will be significant. Adhanala we will not be able to neglect it. Okay, but if we are considering gravity means, paranga, upward force and the upward thrust dana minus u dm by dt. Downward force is what? Weight. Because of them, it's say, and the rocket acceleration is a. Then what is the formula? Net upward force means what? Upward force minus downward force. Upward force is thrust minus downward force is what? Mg. Okay, is equal to what? Mass of the rocket into other acceleration. So this is the equation which represents the thrust to the acceleration of the rocket. Is the equation which represents the thrust to the acceleration of the rocket. Okay, we have to keep one thing in mind clearly, that the mass of the rocket will be changing with respect to time. M order value constant kadayadu. So m value will keep on changing with respect to time. Okay, so this is what we usually get questions from. So NEET lo we got questions only from this thrust formula based panida, we got the questions. Okay, so one where we neglect the gravity. When the thrust is very, very high, or we go very far away from the surface of the earth. Appan theriyuma, we can neglect the gravity effect. If you are considering the gravity, means the net upward force will be what? Upward thrust minus weight of the rocket. Okay, so this will give us what is the thrust formula. So we will be able to know what is the acceleration generated inside the rocket. What is the acceleration generated inside the rocket? Okay, va? Now we'll go and look at what type of questions have come for us in the previous years. So I think all the 3 questions that I have taken, right, they're all from the previous years. Okay, 600 kg rocket is set for a vertical firing. Generally appadida. So we'll keep our rockets for the vertical firing. Okay, vertical firing means what? Exhaust gases, they'll be coming back, okay, or downwards. What is the mass of 600 kg? So if the exhaust speed is 1000 meter per second, means u is what? 1000 meter per second. U value, what is the u value? 1000 meter per second. Okay, the mass of the gas ejected per second to supply the thrust needed to overcome the weight of the rocket. What they're asking, they're saying what is the mass of the gas ejected per second, means they're asking the rate of the exhaust gas, so that the thrust provided, right, is able to overcome the weight of the rocket. We have to consider that the rocket is on the surface of the earth, so we'll take the g value as what? 10 meter per second square. Because the rocket is set for vertical firing, means we are keeping it on the surface of the earth. So we'll take the g value to be what? 10 meter per second square. So the thrust required is what? Is needed to overcome the weight of the rocket, means the thrust required is what? Just to overcome the weight of the rocket, which means it will be equal to what? Mass of the rocket into acceleration due to gravity, which is what? 600 kg into acceleration due to gravity over 10 meter per second square, which is what? 6000 newtons. This is the thrust. Already I'm getting a formula. What is the thrust? Thrust is what? The rate of exhaust gases released multiplied by u, other than a thrust formula. This is equal to what? 6000 newtons. U value I'm getting already. What is the u value? 1000 meter per second. So paranga, what we'll get? The rate of exhaust gases. 1000 ones or 1000 sixes? 6. Everything is in the SI system of unit, right? So the rate of exhaust gases. What is the rate of exhaust gas? Means the mass of the gas that is ejected per second. Rate of exhaust gas means what? The mass of the gas that is ejected per second. Other than what is the value of this? 6 kg per second. Check it up, students. What must be answer? 6 kg per second. So like, you look at the questions in the past year, means all of them, they have come based upon this particular thrust formula. You have to confirm whether you are able to get the answer or not. So what is the answer for this? Option C, Dana. Check pannunga, what is the answer for this? You must get it as what? Option C. The thrust formula, they are saying, should overcome the weight of the rocket, which means thrust is equal to mg. We are putting the thrust formula is equal to what? Mg. Okay. So அடுத்த question போல பாருங்க. இங்க என்னது? A 5000 kg rocket is set for the vertical firing. இங்கயா படிதா? Is set for the vertical firing means what? We are trying to fire it from the surface of the earth. 5000 kg. The exhaust speed u 800 meter per second. To give an initial upward acceleration எவ்வளவு வேணும் நமக்கு? upward acceleration we require what? 20 meter per second square. The amount of the gas ejected per second to supply the needed thrust. இதில் என்ன, they are asking us to take the g value as what? 10 meter per second square. இங்க பாருங்க, we will get what? Because of the exhaust gases, we will get the upward thrust. But என்ன தெரியுமா, we are firing the rocket from the surface of the earth. So அந்த rocket weight நம்ம neglect பண்ண முடியாது. இன்னொன்று என்ன தெரியுமா, நீங்க பாருங்க, what is the net acceleration? அந்த rocket net acceleration அல்லது 20 meter per second square. It is actually comparable with our acceleration due to gravity. So we cannot neglect. இதுல gravity, the gravitational force நம்ம neglect பண்ண முடியாது. ஓகேவா? So இப்படி தான் நம்ம பார்க்கணும். How we will know whether we can neglect the gravity or not? One is generally, right, when we are firing it from the surface of the earth, அங்க என்ன, we will not neglect the gravity. அது ஒன்று. ரெண்டாவது, if you look at the net acceleration value, பாருங்க, what is the net acceleration value? 20 meter per second square. It is comparable to g value தானா? So we will not be able to neglect the weight. So what is the thing we have? The net upward force means upward thrust minus weight is equal to mass of the rocket into upward acceleration. இங்க பாருங்க. So the minus mg நம்ம right side எடுத்துட்டு போனா what we'll get? The upward thrust is equal to what? Minus right side போனா it will become what? Plus தானா? So mg plus ma ஆயிடும். So m அப்படியே காமன் எடுத்தா it will be what? m into g plus a. m எவ்வளவு பாருங்க? 5000. Everything is the SA system. G எவ்வளவு? 10. A 20. So then is 30. So 5000 into 30, what is it? 1,50,000. Upward thrust will be what? In terms of the SI unit, which is newtons. What is the upward thrust required value? 1,50,000 newtons. So what is the upward thrust required value? 1,50,000 newtons. 5,000 into 30. Okay, va? Now the upward thrust already I'm telling you, what is the formula for the upward thrust? Upward thrust value is 1,50,000. Upward thrust formula is what? The rate of exhaust gases into U. U of 800, right? Idhula enna 100 8s. Adukapra indha pakka or 100 cancel aayidum. So what is it? On the 8 அப்படியே left side it will go to the denominator. பாருங்க, the rate of exhaust gases, right? What is the rate of the exhaust gases? What is the rate of exhaust gases? It will be what? 1500 by 8. Is the rate of the exhaust gases. Unit and SI unit dana. So it will be in terms of what? Whatever the value we'll get in terms of the kg per second. So 1500 by 8. Paranga, 8 ones we'll have 7. 8 8s 64 means we'll have 6. 8 7s 56. We'll have 4.5. So what varum? 187.5 kg per second. What is the answer for this? 187.5 kg per second. Paranga. Vanada. So you get the same answer. See all the questions. So all the questions have come from only this particular relation. What is it? The thrust formula. Avlada. Next, look at this question. Not this question, this concept. And we said that mostly we will be interested in knowing what will be the thrust formula based questions. But one of the other area that they have not asked in the past years, or they have not touched, is this velocity of the rocket. So A velocity concept is important is because obviously whenever you're firing a rocket, right, you want the rocket to cross certain, like, the layers of atmospheres. You will have, the rocket must have, like, if you are looking at the people who monitor the rocket, right, so they will be monitoring whether the rocket is having some particular value of velocity or not when it is reaching a certain level of height, because only then the rocket will be able to propel up. Illana, the rocket will actually not be able to reach the target height or target orbit. So the velocity of the rocket, right, will be a very important factor. So people always try to make sure that the velocity of the rocket is maintained at the required threshold values. Okay, but how do we find the velocity of the rocket? So what is the method to find the velocity of the rocket? So already we know the thrust equation. We will be able to find what is the velocity of the rocket. So for example, for the rocket, right, if you consider initially mass is m0 and velocity is v0, generally v0 will be 0, because at the launch pad, right, rocket will not have any velocity. But if you take the initial velocity is v0, and at any time during the journey, we will take the mass to be m and the corresponding velocity is v, because mass of the rocket keeps changing. So we will be interested to know the velocity, how it is going to depend upon the mass, how the velocity of the rocket is going to change with respect to the mass of the rocket. Okay, and Asanamadri, this particular area, right, they have not touched before, so we may have chances of getting questions on this, but then we'll have straight formula. So the derivation we'll look at the formula and questions will be coming based on the formula only. Okay, so what is the equation we have? We have equation, thrust equation, where we neglect gravity. Where we consider the gravity. First we'll start with neglecting the gravity. Adanadi minus u dm by dt is equal to what? Mass of the rocket into that acceleration. Adana minus u dm by dt is equal to what? Mass of the rocket into acceleration. So acceleration can be written as what? dv by dt. So dt dt cancel out. So minus u, in the right side m, we'll just bring it to the left side. Minus u dm by m is equal to what? dv. We'll integrate it. Integration, left hand side the variable is mass of the rocket. What is the limits of integration? m0 to m. Right hand side the integration is with respect to velocity. It will be v0 to v. Okay, so right hand side integral dv means what? It is like integral dx. What is integral dx? X means integral dv will be what? V. Limits are what? Initial limit is v0, final limit is v. So then it will be v minus v0. That is our RHS integration value. LHS la minus u is a constant, right? Integral m0 to m dm by m. What is dm by m? Integration, it's like what? Dx by x. Now what is integral dx by x? Ln x or log to the base ex. So what is integral dx by x? Ln, natural logarithm. Natural logarithm, what is natural logarithm? The logarithm having a base e. We'll call it as what? Natural logarithm. Okay, so LHS integration, right? Minus u log to the base e. Limits are what? m0 to m means minus u final limit minus initial limit. Okay, now we will have to just conclude this. We got the answer. So once we conclude it, right, already RHS integration value, what is RHS integration value? V minus v0. So LHS mattum nama conclude pananum. So LHS there is a minus here, right? Minus it will become what? The sign change will happen. So u into log to the base e m naught. The minus plus side, plus will become minus. Minus log to the base e m. Already we have a property for the logarithm. Log a minus log b will be equal to what? Log of a by b. There is a property of the logarithm. Another log a minus log b is equal to what? Log of a by b. So we will use that property. So u into log to the base e m naught by m. So this is our LHS. So paranga, LHS is what? U into log to the base e m naught by m is equal to RHS is v minus v naught. So அப்படியே அந்த minus v naught we will bring it to the left. So minus plus ஆயிடும் v naught plus u into log to the base e m naught by m, that is v. Is the velocity. How the velocity of the rocket will change with respect to time. Idhula time kadayadu, we are instead of time what we are representing? The mass. Instead of time representing what is the velocity function with respect to mass of the rocket. So paranga, this is what is the velocity formula. So velocity of the rocket when we neglect the gravity, what is it? V naught into u, sorry, v naught plus u into log to the base e m naught by m. Okay, so idhula what is v naught? The initial velocity of the rocket. M naught is what? Initial mass of the rocket. M is the present mass or whatever the mass that is available at the time. We can understand one thing, the relation. As the rocket is propelling, M value will keep decreasing. As the rocket is propelling, M value will keep decreasing. See, M is in the denominator, right? As the M value is decreasing, the overall logarithm value will increase, which means V will keep increasing. So as the mass of the rocket decreases, right, the velocity of the rocket will be keep on increasing. So when you say mass of the rocket decreasing means, what is it meaning? It is meaning that we are propelling. So as you are propelling more and more, the fuel is going to be consumed more. So mass of the rocket, because fuel is inside the rocket, right? If the fuel is more and more fuel is consumed means the rocket mass will keep decreasing, because rocket mass, right, will mainly consist of two parts. One is the shell mass, which is the shell of the rocket, equipment, plus the mass of the fuel. That's how we'll divide. So mass of the rocket will be what? Mass of the shell plus mass of the fuel inside the rocket. Okay. Mass of the shell will not change. Even, see paranga, when the entire fuel is consumed, right, the mass of the rocket will be just equal to what? Shell mass of the rocket. When the entire fuel is consumed, so this mass of the rocket, it will not become zero. Why? Because mass of the rocket is not just the fuel part. Otherwise, you will have these, satellite or whatever the things that are there, equipment, everything will be there. So the shell mass of the rocket plus mass of fuel, that is the overall mass of the rocket. So when we say entire fuel is consumed, all the fuel is consumed, right, then the M there will be what? The M represents what? The shell mass of the rocket. The M there represents what? The shell mass of the rocket. In that case, right, the velocity of the rocket is going to be the maximum value. So what we call it as? The maximum value, we call it as the burnt out speed of the rocket. So the speed attained by the rocket when complete fuel gets burnt. Adu eppadi nama calculate pandrathu? The mass of the rocket will be substituted with what? The shell mass of the rocket, means we have consumed the entire fuel. Then that corresponding velocity will be what? This will be the burnt out speed of the rocket. All that. So that is what is the maximum speed that the rocket can attain. Adukku mela we will not be able to attain the higher value for the speed. From whatever the fuel that is there, we can maximum attain this burnt out speed of the rocket. Okay. So this is about the rocket velocity formula when we neglect the gravity. Okay. Now we look at what if we consider the gravity. So now we are done, the rocket velocity when we neglect the gravity. Now we will look at the derivation. See, we are spending some time to do the derivation so that you guys can understand how it is coming. It is basically coming from nowhere. It is coming from our thrust equations only. And the thrust equations, but for us, right, if at all we are getting questions, means we should be ready to remember the formula and then derive. So final examination we cannot derive all these things and then solve the problems. Otherwise we will lose the time. So we should remember those final formulae. But derivations we will be able to feel the comfort. Okay, so we'll have more clarity on that. Okay, so we will do the derivation for the velocity of the rocket or the speed of the rocket by considering the gravity. So what is the equation we have? Minus u dm by dt minus mg is equal to ma. Is that a thrust equation? So ma ku badala we will write as what? dv by dt. So first multiply both sides with dt. dt which number two side la multiply pannu. Okay, what is it? Left hand side la minus u dm minus m g dt is equal to m dv. So the dt cancel dt numerator here dt will be getting cancelled. Okay, now divide both sides by m. Divide both sides were divided by m. Minus u dm by m minus g dt is equal to dv. Almost we have got the same expression like the one before. Almost we are getting the same expression like the one before. Where there is one small change. And the left hand side we are getting the term minus g dt. Left hand side we are getting the term minus g dt. Okay, so if you take the integration approach, right, what is going to happen? We are going to get the integration in terms of the time also as a variable. So initial time we will take it as 0, final time we will take it as t. So left hand side integral minus u dm by m, limits m naught to m, minus integral g dt 0 to t is equal to integral dv v naught to v. Already we have done this previous. What is it? It is going to give us what? U log to the base e m naught by m. So we already done this. Integral of m naught to m minus u dm by m. The value u into log to the base e m naught by m. G is a constant. Integral dt will be what? T. Means it will be t minus 0, which is t, is equal to what? This is already we had done previously. What is it? It is going to give us v minus v naught dana. So we are looking for the v value. So on the right side v naught minus v naught. We'll bring it to the left side. V naught plus u log to the base e m naught by m minus gt. All of the one difference. Minus gt term varudhu. So same as the previous formula, but we are getting what? Minus gt. Same as the previous formula, but we are getting minus gt. Because the rocket is propelling forward, right? The velocity is upward direction, and the acceleration due to gravity is downwards. So it will produce its component. What is the component? The velocity component will be gt but downwards. Adhanala it will be what? Minus gt. Okay, so what is the velocity of the rocket formula? When we consider the gravity, v is equal to what? V naught plus u log to the base e m naught by m minus gt. All that. Okay, so these two formulae we have to remember. What is the formula? When we neglect the gravity, v is equal to v naught plus u log to the base e m naught by m. Consider the gravity means just that minus gt will come, that's it. And if they are asking what is the burn torch speed of the rocket, means what? The mass of the rocket m, the present mass of the rocket, right, will be taken as the shell mass. Okay, mass of the rocket will not become zero at any time. Why? Because inside the rocket, along with the fuel, we are also having the other setup, everything. Okay, so that is what we call as the shell mass of the rocket. Okay, va? So this is about the velocity formula. So just we need to remember the formula, that's it. And we may get some questions. கண்டிப்பா ஒருவன் சொல்லிட்டு சொல்ல முடியாது, but we may get some questions. And already we have got some questions on the thrust formula. Maximum they may give the questions again on the thrust formula itself. So you have to make sure that on the original you should be thorough. But as an extension, right, because most of the students might not look at this, we are looking at these formulas so that by chance there is a question coming on, it means we should take the advantage. Okay, va? So this is about the rocket propulsion, and the next concept, right, probably we will look at this in the next class, the observation. Like, you know, whenever we talk about, say, the objects are moving across the pulley, or there is a block which is moving on the horizontal table, or we say that there is a block which is sliding on the inclined plane, like whatever we talk about the motion, who is the observer for that? Yoshi Paranga, who is the observer? Because whenever I say that, okay, so there is a pulley system, blocks are moving, we are intuitively, we are assuming that somebody is standing outside and observing this. Somebody is standing outside and observing the pulley system. Somebody is observing this by standing outside. Somebody is observing this. So observer, right, generally we are thinking of as a person who is at rest or who is stationary. So whenever we talk about the motion, right, so we are not saying, you know, because motion is relative, right? And already kinematics, what is it? Motion relative. When we say displacement, it depends on observer, right? When we say velocity, it depends on the observer. When we say acceleration, it also depends on the observer, right? So motion, it's a relative concept. So like all the problems we discussed so far, right? So we were generally using this. There is a pulley system. What is the acceleration? We are not even telling who is the observer. Depending upon the observer, right, the acceleration that is seen will change. And if you are asking what is the velocity, velocity also is going to depend upon the observer, right? So in all these discussions, intuitively we are considering that, okay, there is somebody who is standing outside, who is probably stationary or rest, and he is looking at everything. Appadha namma oru understanding irukka. But this can be changed. Like we may have questions where they can ask us to tell about the acceleration or the motion, study of motion with respect to an observer who is not stationary. Okay, so there comes the concept of what is an inertial frame of reference and what is a non-inertial frame of reference. Okay, va? So maybe in the next class we'll start with the discussion on what is the inertial frame and what is the non-inertial frame of reference. Okay, so next class you try to solve some more questions on the rocket propulsion. Okay, next class.